Welcome to Survey Matters with Duncan-Parnell. My name is Mark White, and I'm the Training and Support Manager for DP. As part of our Back to Basics series, we're going to do a Getting Started guide today for Trimble R980s, the TSC5 data collector running Trimble Access, doing RTK with the internal radios. And in this video, we're going to cover what comes with all this gear, how to set it up, how to charge it, how to create jobs in Trimble Access, projects in Trimble Access, how to start the base receiver, how to measure points with the rover, how to stake out with the rover, and then finally wrap it up by exporting a point file and transferring it to your office computer. So stay tuned, but before we get started, please like and subscribe. Let's take a look at the R980. So this is all the stuff that typically comes with an R980. It's going to come with 2 lithium-ion batteries and a dual slot charger to charge those up with. And then you have your power cord for the charger. Now, this dual slot battery is actually, or battery charger is actually made to charge 3 different batteries that Trimble sells. So it's got an insert in here. The front will charge the MT1000 battery, and it's sideways here with the insert out. It'll also charge the S7, S5, SX12 type batteries. But for this, for the R980, you want to make sure that those inserts are in there. And then this battery is just going to go contact to contact, and it'll click in for a nice secure fit. These batteries are lithium ion. They take about 3 hours to charge, and they'll last roughly 4 hours per battery in the receiver, depending on whether it's being used as a base or a rover. You may get a little more, you may get a little bit less, but generally 4 hours per battery, 3 hours to actually charge. All right, there is a conditioning button on the front of this. That only works for the S7 and S5 batteries. You don't need to worry about conditioning these batteries for the R980. So that's the batteries and the charging system. You also get the dual band antenna. You'll see it's got yellow and blue on it. This is a 450 and 900 megahertz radio. So this antenna is used for both of those. Now this antenna will screw right on the bottom of the receiver. And when it screws on there, all you have to do is get it finger tight. Okay. Don't crank down on it. You can actually strip the piece out on the receiver or break the antenna if you go too tight. And we've seen guys do that. So just finger tight is good. When you're doing an RTK base rover survey using the internal radios on the receiver, you need that antenna. So make sure you have it with you. If you're doing internet-based stuff, you don't need the antenna, but to use the internal radios, you need that antenna there. All right, so a couple other things on the bottom of this receiver. You've got port 1 is the I/O port. That is for power and data. Close that. And then you've got the USB port as well. And you do get a couple of cables with the receiver, USB cables. You get a short cable that'll plug into that USB port, and you can put a USB drive in there, and that'll automatically download any static data that's been stored on the receiver if you're doing a static campaign there. And then also you get one that'll hook to your computer here and hook to the USB port on the receiver here to update firmware, things like that. Okay, so those cables come with it as well. On the side of the receiver, we have the battery door. That'll open up like that. And the battery actually has an arrow on it. And then there's an arrow on the receiver here. It's pretty small. You're not going to be able to see it on the video, but there is an arrow there. Just line up the arrows and push the battery into the little bail. The battery bail comes across it and clips in place. Battery is spring loaded, so it'll come out easier. So just make sure that bail goes across it. There's also a button on the battery you can press that will show you how charged up the battery is. Once the battery's in there, just close the door and it'll click shut. Now also under this battery door is where the SIM card slot is located. So we're not going to use internet on this particular getting started guide, but later on we will. But if you need to put a SIM card in, that's where it goes. And just a quick note on SIM card size. Your cell phone is going to usually have what's called a nano SIM. That's this little bitty SIM card there. And then the next size up is a micro SIM. and then you have your standard SIM card size. You need the standard for the R980, okay? The nano or the micro aren't going to fit. Now, if you get a nano SIM card from your IT department, or you just get one from your cell phone provider, and they don't have these, you can get these online. You know, just look for a standard SIM card adapter, and then you can put the micro adapter in it and the nano adapter in that, and boom, you've got a SIM card that will fit in the R980. The contacts on the SIM card, whoops, a little gold side here, the contacts are going to face up when you slide that in there. So standard size SIM card, again, it's right inside the battery door. Contacts will slide up. All right. Now here's the on-off button for the receiver. Just press it once and the lights will come on. After a few seconds, all the lights will go out, the power light will remain on. And as the unit boots up, the first thing that's going to come on, besides power light, is the Wi-Fi light. That's for the Wi-Fi that is inside the receiver, will allow you to do some configuration. Then the satellite light's going to come on once we start seeing some satellite signal. The radio light will come on when the radio is broadcasting or receiving. And then the little arrow button here is if you're logging static data to the receiver, that arrow button will come on as well there. It's not logging any data right now, but this receiver had been configured to have the radio working, so the radio did fire up for us there. Now, to turn it off, all you got to do is hold the button down for about 2 seconds till all the lights go out. That power button light will stay on for about 5 seconds as it boots down, and then it'll go out, and that'll let you know that the receiver has turned off. Now, if you ever need to reset this, when the unit is turned on, you can hold the power button down for 15 seconds. All the lights will go out. Then the satellite light will come on at 15 seconds, and then you can let the button go. That does a factory default reset on it, and it clears the ephemeris file. If you hold it down for 30 seconds, so after 15 seconds, the satellite light will come on. If you continue to hold the button down, at 30 seconds, that satellite light will go out, and then you can let go. All the lights will come on, all the lights will go off. It'll eventually reboot. That will clear any application files that are on the receiver, and it will also erase any static data that's been stored on the receiver as well. And then also, if you ever log into the web UI and you don't know the password, holding that power button down for 30 seconds, and that'll reset the password on the R980 back to the default. All right, so that's a good overview of the R980 here. Now let's take a look at the TSC5. Now let's take a look at the TSC5, just a quick overview of it. So first of all, just like the name implies, it has a 5-inch screen. Does come with a screen protector. Now we always put these on before they leave the shop, but if you ever get one, and it doesn't have the screen protector on it, screen protector will be in the box. Put the screen protector on. It's very important that you have that on there to protect the screen. All right. It is an Android-based device. We have an Android operating system on the TSC5. Has a forward-facing camera and a rear-facing camera on it. So just like a phone, has camera on both sides. You can take pictures with it. Here on the front, it does have the Android keys up here at the top. So you've got your back key, you've got your home key, and you've got your overview key up there, all right? So if you ever want to get back to the home screen, you just press home. If you want to go back one, press the back. And if you hit the overview, it'll show you all the open windows you have, and you can swipe up to close those windows. Okay, so standard keys on an Android phone there. As we work our way down the keypad, do have a multi-direction tool right here and an enter button in the middle. You've got 6 function keys up here on the sides and 6 more function keys down here just above the QWERTY keyboard. Those are nice because in Trimble Access, you can use those to set up certain functions for kind of like hotkeys on there, right? Then you have your number pad here, on-off button right here. Press it once to turn it on. When it's on, if you press it once, it's going to put it in sleep mode. If you press and hold it, it will give you the option to turn it off completely. All right, then real quick down here at the bottom, you do have a function key that will allow you to get to anything in yellow above the physical keys there. And your caps buttons are down here on the up arrow and the Z as well. All right, so that's everything kind of on the front of this guy. If I turn it over, now this is one of our rental demo units, so it does have an EM120 attached to it for a for use. It's a radio for use with a Trimble robotic station. So yours may not have this if you're only doing GPS, okay? But you can use this with your robot as well. It does come with a stylus and a stylus holder on there. And then there is one case cover back here, and I've kind of got it loosened up. You can take this on and off with a small Phillips head screwdriver. This brings up another point. Keep a small Phillips head screwdriver in your truck. We get calls sometimes for guys that need to access this or need to take their radio off or put a radio on and they don't have a screwdriver out there in the field. So keep a small screwdriver in your truck. I've got these loosened up already. Let me just take them off all the way so I can show you what is under this cover on the back. That should do it. Yep, there we go. So in here, you can put an extra long life battery. Comes with an internal battery that is sealed inside the unit. Charges through a port on the bottom. It's just a C connector, so you get your standard, C cable and charging block with the unit. So it's going to charge through there. You can also use that C port to connect it up to a computer, just like you would a phone if you wanted to send data back and forth that way as well. So that's on the bottom. But again, you can put an extra battery into this part right here, put a cover on it there, you're good to go. That'll give you extra runtime. Now, the internal battery is going to last you all day, but if you ever need extra battery power, that can be done as well. Also, if you want to put a SIM card in this guy to do internet-based rover or just to connect, to send data back and forth or to get on a network RTK solution, the SIM card will go right in a slot here. This door will pop open, and this takes a micro SIM card. So we looked at the 980 just a little bit ago. That takes a standard SIM card. The TSC5 will take a micro SIM card. IMEI number, if you need to give that to your IT department or your cell phone provider, that is right here on this barcode that you'll see in there. I'll also show you where it is inside the software. So let me just put this cover back on. I'll tighten it up just enough to keep it from falling off. Maybe. There we go. All right, so that should keep it from falling off there. Now, like I said, to turn it on, it's just one click. And if it's completely off, this one was in sleep mode. If it's completely off, it's going to take about a minute or two to boot up. It'll go to a white Trimble screen, then it'll go to a TSC5 screen, and then you'll get your Android screen. I'll click it one more time. Sliding up will unlock it. Now I'm going to turn on screen recording so you guys can follow along with me, and I'll show you a few things about the Android operating system. All right, so I turned screen recording on so you guys could see the screen, and I could just cover a few things for you as far as the Android operating system goes. Now, you'll see here the Trimble Access button is actually on the home page. When you first install it, sometimes Trimble Access will go on the second page, but you can tap and hold on it, drag it over to the first page. That way it is on there. Again, you've got this middle button here, right there, that'll take you back to this page all the time. The overview will show you if there's anything open, and the back button will take you back where you were. So those are always handy if you're not familiar with Android operating systems. Now, if I swipe down from the top, that is going to give me some of my quick settings there. So I have internet. If you need to connect to a Wi-Fi, connect to a Wi-Fi source anywhere. You've got your internet. You've also got Bluetooth. Want to make sure that's on. And then you'll see here where it says finger, you can tap and change how the touchscreen is set up to finger, stylus, or glove. So set it up however you like to use it. You also have a flashlight on here. I'll point that down so I don't blind the camera. You can use that if you're ever working in low light conditions there. And then, a few other things down here at the bottom. One important one is you see airplane mode there. Make sure your unit does not get set in airplane mode or you're not going to have Bluetooth or wireless, right? If I swipe over to the right, auto rotate is one that comes up every now and then. By default, that's set to off so that your software programs are going to be, up and down in landscape mode here, but you could turn that on if for some reason you needed to set it into portrait mode. I've had guys tell me they've had to do that in certain situations. So, or you know, somebody accidentally turned that on and now their screen's moving with them all the time, that's where you would go to turn it off, right? You also have the screen recorder, which I am using now. Then down here at the very bottom, we've got our settings icon, our little gear. And this is where all your settings are. If you're familiar with Android phones, it's the same thing, or it's kind of like your settings in an iPhone if you're familiar with that. So you've got network and internet, you know, Bluetooth pairing, connected devices. There's all your apps, notifications, battery, storage, sound, display. And if I scroll all the way down here to the bottom, about device, this will show you, if I scroll a little bit more, there's your IMEI number again, your Android version, all that kind of information. And then under system, you can get some good information as well, like language, date, time, backup, system updates, reset options, all that good stuff is under system. So just a lot like a phone there. Now, if I hit the home button and go back to the home, if I want to access any apps that I have on here, all I got to do is swipe up and there's all my applications. All right. Like I said earlier, to turn this guy off, if I tap and hold on it, you'll see you get a shelf mode. That's if you're going to let it store for a long time. You want to put it in shelf mode, then power off and then restart. Now, I would recommend that at night, don't just put this thing to sleep and put it on charge, but go ahead and power it off. And then the next day, power it back on. You know, while you're working during the day, you can just tap the power button, put it in sleep mode, but power that guy off at night, let it reboot, restart. That's just good for it. And so, like I said, if you ever have to store it, do shelf mode. If you ever need to reboot it, use the restart there. All right. So I'm going to go back to the home screen. That's just a quick overview of the TSC5. Next, we'll take a look at Trimble Access, get a survey style set up, and a job and a project. Before we create our survey style and our project and our job, I want to go ahead and pair up the TSC5 with our two R980 receivers via Bluetooth. That way the data collector will be all set to talk to them. So we'll open up Trimble Access, and I'm doing this with Trimble Access version 2024.11. That was the latest version available at the time of this recording. So when we get to this screen, we'll tap the menu button at the top left, go to Settings, and Connections. So up at the top left, we have the Bluetooth icon, or the Bluetooth tab, I should say. Tap Search down at the bottom, and the data collector is going to start looking for available Bluetooth devices. Now, I found one of the R980s, the one ending in 945. So I'll go ahead and tap it and choose Pair. Now, I want to use 945. That's this one here. I want to use that as my base. So I'll tap Pair when this message pops up. And then here, when I'm prompted, I'll do the drop down and choose to connect to GNSS base. All right. Doesn't really matter which one I choose. Just choose whichever one you want to run as the base, whichever one you want to run as the rover. But just remember which one's which so that when you set them up, the data collector's talking to the right one. I'll tap Accept there. And now we'll tap Search again and look for the serial number ending in 206. That's going to be the one I want to use for my rover. Okay, now sometimes it'll search for them and it won't find them. If it does that, if you go about 30 seconds, a minute, and it hasn't found it yet, you can tap this clear button and that will begin the search over again. And a lot of times that'll cause it to find it. If for some reason you go 2 or 3 cycles of hitting clear and it doesn't find the receiver, just turn the receiver off, then turn it back on again. And normally that'll make it connect up. So I'll let it run through one more time. If I don't see it, I'll go ahead and power cycle the receiver. It's just good troubleshooting for you guys. Troubleshooting tip for you guys there. All right, so it's not popping up yet. So I will power cycle the receiver, hold it down for 2 seconds. You see the light goes off like we talked about earlier. Power light stays on for about 5 seconds. Once that light goes out, I'll just hold the buttons down till all the lights come on. We'll let this guy sit for just a few seconds till it boots all the way up. Tap the clear button and search for it again. So again, you can use the clear button to cause TSC5 to search again. Still doesn't find it, just power cycle. That'll normally make it find it. So we'll give it about 15, 20 seconds. It should pop back up this time. All right, so there's our receiver 206. I'll tap it. Choose to pair, Again, when the message pops up, when we're prompted, I'll choose to pair that. And then this time we'll set it as a rover instead of our base. So pair. And this time it automatically pops up to the rover, so I'll tap accept. Now I've got this one 206 set as the rover, this one 945 set as the base. I'll accept that, and we're all set to start working on our survey style next. So now that we have our Bluetooth with the receivers done and set up in Trimble Access, let's go ahead and create our survey style. I'm going to put my glasses on for this so I can see the data collector a little bit better. The gray hair is real. I'll tap the menu at the top left. We'll go to settings, and then we'll tap survey styles. Now, these are the built-in survey styles that come with Trimble Access, and there's already one in the list for RTK. You could create a new one, or you could just edit this one. I'm just going to edit this one for simplicity's sake, okay? I'll scroll down, tap RTK, and we're going to start with our rover options. So I'll tap the edit button. We are doing an RTK survey, so that's fine. Our broadcast format, when we're using Trimble receivers and we want to get all four of the constellations, GPS, GLONASS, Galileo, and Beidou, we want to use CMRX, okay? That's going to give us everything out there in the sky. In this case, we are using an R980 internal. If you were using something else, you could choose it from the list. And we're going to be measuring to the bottom of the quick release for the rover, because I'm going to be attaching it to a 2-meter pole. So we'll use the bottom of the quick release that we looked at the beginning of the video. Since I know what my rod height is going to be, I'm going to go ahead and type in 2M for 2 meters, since I'm using a 2-meter pole. You don't have to worry about the serial number there. The next section is the tilt functions. Going to use IMU tilt compensation. We're going to leave it on for this survey so we don't have to plumb it up, except for when we're shooting control points. The E-bubble, if you like to use the E-bubble instead of using the bubble on your pole, you can leave that on. I'm going to turn that off. I prefer to use the bubble on the pole, or I like to use the IMU. You can turn that on and off either way. The AR viewer, I will leave that on. We're not going to use AR in this particular video, but we will in a later one. That allows you to load a 3D model in here and use the camera on the back of the data collector with information from the GPS receiver to be able to view that model overlaid in the real world. All right, we'll leave that on for now. Station index, we're going to leave that set to any, or if you know there's a certain number that you're going to use, you could type that in here. We'll talk about that a little bit more when we look at the base options. Prompt for station index, I will leave that on. Satellite differential, that's for using SBAS, that sort of thing. Since we're going to use radios to send our corrections, we're going to use RTK, we don't need our satellite differential on. Elevation mass, standard 10 degrees is fine. That just lets you know that if satellites move in the sky, the lower they get on the horizon, the more atmosphere they have to come through, the more their signal can become distorted. We don't want to use any satellites that go below 10 degrees on the horizon, or they're 10 degrees above the horizon. Once they drop below 10 degrees, we don't want to use them anymore. PDOT mask is the positional dilution of precision. That's just how well are your satellites spread out in the sky, okay? That's a unitless number, but 6 is the cutoff for doing RTK, so we're going to leave it at the default there. I will scroll up a little bit. I'm going to go ahead and turn on all the different signals that are available, and that's just because there might be some of you guys watching this video in other parts of the world. I'm on the East Coast of the United States. I'm not going to get QZSS or NavIC. QZSS is a local GPS system mainly centered around Asia Pacific, Japan in particular, and NavIC is a constellation that covers India. So I'm not going to see them here, but in case some of you guys are, we'll go ahead and turn that on. Turn on L5. The way I look at it is turn on everything. It's not going to hurt anything if they're on. If you can't see them, you're just not going to get them. But if they're unchecked here and you could use them, you're not going to get them because you told it not to, right? So I'm just going to turn everything on. Roving precision, I'm going to leave that on auto tolerance. Now, what roving precision does is it takes into account the precisions that are entered in here, and that's usually based on the model of receiver that you choose from the list. and the distance, the PPM value, the distance you are away from your base station, okay? Now, we're on the rover options. We're not on like topo point or rapid point or observe control point. We'll look at those in just a minute. They each have their own precisions, but roving precision, this is where you're going to get the little green check or the red X at the top right of the screen that tells you whether or not it's good to survey. Your data is good enough to survey. Your receiver has converged within this amount. Now, if there's an amount that you want to set it for, you can tap that and you can change these here. Just understand that when you do this, it's not going to factor in the length of the baseline, okay? So it's recommended that you leave auto tolerance turned on. But in a case where, this comes up is maybe you're working in the woods and you're just doing something like clearing limits, you don't need as great an accuracy, you could turn that off and you could, turn your accuracy up a little bit, and then use that for something like clearing limits or wetlands or something that doesn't require as great of accuracy. But we're going to leave that on auto tolerance for now. Exfil uses Trimble's RTX satellite service to send corrections for short term. If you lose radio link, it'll allow you to survey for a few more minutes without radio. So, it always happens at the end of the day. You got one more point to shoot, you get out of radio range, and Exfil will allow you to get that point. Okay, it's only going to last for a couple of minutes, but it is handy if your radio is spotty, and it will allow you to pick up a few points for a couple of minutes. So we will leave that on. Okay, and that's everything for the rover options. I'll tap accept down at the bottom. Now let's take a look at the rover data link. We are using a radio, and we're going to use the internal radio for the rover and for the base in this survey example that we're doing. So I'm going to go ahead and hit connect and show you guys what the settings are and how we need to match these up, okay? Now, an R980 has a 450 megahertz radio or a 900 megahertz radio. So that's the first thing you have to decide. For this example, we're going to use the 450 megahertz radio. This is my rover, so I want my radio operating mode in rover. That's good. Now, I want to choose a frequency that I'm licensed for, okay? You do need to have an FCC license to run radios in an RTK survey, all right? So you can talk to your dealer about that, but you do need to make sure that you have an FCC license when you're running your radios and doing an RTK survey. I'm just going to leave it at that. So choose the frequency and the band that you're licensed for. I like to go with something that's kind of towards the middle. You get more signal strength out of the bands that are in the middle there, especially 464.50. So I'm going to set it to that. Now you need to make sure your base radio mode is set. For a Trimble receiver here, we're usually going to use TrimTalk V1, okay? That's just the over-the-air language that Trimble came up with. These other ones in the list can be used as well, but these are the ones that Trimble came up with. And 4800 is going to give you the longest range, but the shortest battery time, okay? 9600 is going to give you I think I said shortest range. 4800 is going to give you the longest range with the shortest battery time. 9600 will give you the shortest range but longest battery time, and 8000 kind of splits the difference there. I'm going to go ahead and run at 4800. It will cause the base receiver to run just a little bit hotter. The battery time is going to be a little bit less, but it will give me the best length there for my radio, okay? So once I have all this, now I'll need to make sure I remember these settings or I write these settings down, because I'm going to have to configure the base the exact same way, except for telling it the radio operating mode's a base. But I need to know that it's 450, I need to know the frequency, and I need to know the base radio mode. So write those down if you can't remember. We'll accept that. That radio is now set. And that's usually probably the biggest phone call we get from people when they're doing base rover, especially for the first time. They're not talking to each other, and it's because one's on one frequency, one's on the other, or one's on TTV1 at 9600 and the other's at TTV1 at 4800, okay? They have to match up. I'll tap accept there. Now let's take a look at the base options. Now we want the base options to pretty much match the rover options so that the two will be singing off the same sheet of music, right? So we're doing an RTK survey. CMRX is our broadcast format. We are using an R980 internal. Now, depending on how your setup is for your base, if you've got a base kit, it's going to have a little lever arm that sticks out that you can do your measure up to make it a little more accurate. So you could choose lever of an R980 extension there. For this example, I'm just going to use bottom of quick release and use the fixed height pole again. And now if you know you're using a fixed height pole like 2 meters, you can put that information in there. If you're using a tripod and that quick release or the lever, it's going to be different every time. So I would recommend don't put in an antenna height. Okay. I'm going to use a 2 meter pole with a tripod bipod to hold the thing steady. So I'm going to go ahead and set 2 meters in. Now here's your station index. This is a number we talked a little bit about just a minute ago in the rover options. This is a number between 0 and 31, and all it is an identifier that your base station is going to send out that this is your radio talking. Okay, so that can be valuable if you're in an area where there might be a lot of other people doing RTK and you want to make sure you're connected to your base station and not another surveyor's base station. All right, so this is set to 22. Again, it can be 0 to 31. You can pick your favorite number. Just remember what it is, and we'll see when we go out in the field that number is actually going to pop up when we connect to the base to validate that we are connected to our receiver. All right. Again, elevation mass, same as on the rover, 10 degrees. We want to turn on everything. Again, if we turned it on in the rover, let's turn it on in the base, and then we'll tap accept. Next thing would be our base data link or the base radio. So it is going to be a radio, but remember for this survey, we are using receiver internal. So I want to switch over to my base station. That's going to unplug the Bluetooth from the rover and hook up to the base station. And we want to get those settings set so that it talks the same frequency and the same radio mode as the rover was, and that way the two will talk to each other. So it's switched over now. I'll hit the connect button. It'll connect up there. Again, we're using the 450 megahertz band. This one's going to be our base, so I'll switch that over. We're going to use 464 5000, so I'll leave that alone. I didn't have to change that. Trim Talk V1 at 4800. That's what the other one was set to. That gives us the longest range, shortest battery life. So we're going to use that one. And then we're not using any repeaters. We're going to set the transmit power to the strongest that we can, 1 watt, to get the farthest difference there. And we'll go ahead and tap accept. And now the base radio is set up and ready to go as well. Okay. The key thing there is same frequencies, same radio mode, and then they should talk, right? So we'll accept that. Now let's look at a couple of the different point measurements that we can look at. So topo point. So this is what you would use if you're just taking, like it says, a topo point. Maybe I'm shooting the back of curb, an edge of pavement, an edge of concrete, something like that, okay? And the way it's set up default is our auto step size is 1. So if I store the first one at 100, it's going to go 101, 102, 103. That's pretty normal, but if you need to change that, you can do that here. Then there's our quality control. Okay, by default, it's going to set to QC1, QC2. The other options are QC1 only or QC1 and QC3. Now, this is not going to affect your data. All right, look at this as quality control metadata that can be used back in the office. How this is set is not going to affect your position that you collect with the GPS. QC1, and I'm looking right here in the help notes from Trimble, okay? QC1 is going to give you the number of satellites, the dilution of precision, how well the satellites are spread out in the sky, and the time. Okay, so it's gonna store that information for you. QC2 is going to give you your variance, covariance matrix of the RTK solution. So that can be handy if you're doing a least squares adjustment with your vectors back in the office, okay? And that's why it defaults to QC1 and QC2. QC3 is the error ellipse of the RTK solution. You're not going to use that near as much. So by default, it's set to QC1, QC2. That's what I would recommend leaving it on. Now, I do like to check auto store point. And what auto store point does is when the occupation time and the number of measurements agree with the precision that we set down here, it will automatically store the point. Now, by default, with R980, a topo point is 2 seconds with 2 measurements. So the occupation time is how long the receiver is going to sit there in static mode during the measurement. The number of measurements is how many measurements it's going to take during that time. So this is 2 seconds, 2 measurements. So 1 measurement each second for 2 seconds. If it meets the auto precision down here, which again, if it's on auto tolerance or the precision, if that's on auto tolerance, that is the values that are in here plus the part per million calculation from the baseline, right? So if I uncheck that, you'll see that's at 15 millimeters by 2 centimeters. So if I meet that and the ppm calculation for the distance to the baseline in 2 seconds and 2 measurements, it's going to store that. If not, it's going to keep measuring until it gets 2 measurements that agree with each other and fall into that, okay? Okay, so sometimes people ask me, does it average those 2 measurements together? So again, I want to, right here out of the Trimble help files, right? In an RTK survey, the RTK engine in the GNSS receiver converges on a solution during the occupation, and it is this converged solution that is saved in the job file when the point is stored, okay? So it's the converged solution that happens during those 2 seconds and those 2 measurements that is being stored there. So I'm going to go ahead and accept that. Oh, down at the bottom, there's also auto measure and auto abandon. Auto measure is going to you can walk along. Once you plumb it up, it will automatically measure a point. Auto abandon, if it gets outside of the precisions, it's going to abandon it and start over. Those are not checked by default, and I would leave those unchecked as well. So we'll accept that. Let's take a look at an observed control point. So an observed control point is just what it says. This is what you would do when you're setting a control point in the ground to be used later on, either to set the base on, or maybe you're going to set a total station or a scanner up or something like that. Okay, so Trimble recommends doing 180 measurements for that. That's 1 per second for 3 minutes. All right, and they've done a lot of testing over the years and found that that's kind of the sweet spot. You don't really need much more data than that, but less data than that might not give you the best solution. So 180 measurements over 3 minutes. QC2 or QC1, QC2 is what's getting stored up there. We already talked about that. And you can check the auto store box if you want to or not. I'm going to go ahead and check that. And then the precisions are the same, 15 millimeters by 2 centimeters. I'm going to leave that to auto tolerance, so it will include that baseline length. And I don't like checking the box for auto abandon, because that way, if you set auto abandon, if it gets outside those tolerances, it's going to start the measurement over. And that can get a little aggravating when it keeps starting the measurement over and over and over and over again. Okay, so we'll leave that off. And then down at the bottom are some post-processing times if you're doing static surveys, so don't worry about that. The main thing is check auto store if you want to. And then 180 epochs is pretty standard, so we'll accept that guy. Next will be rapid point, and rapid point is just you hit the measure button, it grabs 1 epoch of satellite data and stores it, okay? So QC1 is the only thing that's up there because there's nothing to compare it to, and your auto tolerance can be left on. You can set auto measure if you want to walk along and just plumb the pole and take measurements as well. I will leave that off for this example, but that's rapid point. We'll accept it. Continuous points. Again, that's when you're riding along on like an ATV, or you mount the receiver on a car or a boat or something like that, and you tell it to take shots every so many seconds or every so many feet. Again, that's just going to be QC1 because that's just a rapid point that's getting stored in succession there, so we'll accept it. Now, stakeout is where I do like to make a couple of changes. There's a lot of different things you can set in here. View before storage, horizontal tolerance before it tells you you're good, all these different ways to view your data here. The main things for me are I like to change the display mode from surveyor centered to target centered. Okay, surveyor centered means I'm still in the middle of the screen and the point I'm trying to stake out is moving around me. That just doesn't work for my brain because I'm the one moving and the point's what's staying still. So I like to change it to target centered so the point I'm staking out stays still and I am the one moving to the point, okay? Direction of travel is fine. Uncheck the box for compass. That tells the software to use the internal compass to stake out a point, and I'm using the GPS receivers, all right? So I don't need the compass on, so I'll turn that off as well. And then the other things I like to change are the point deltas. If you tap the edit button there, I don't always know which direction north and south is. I know I'm a surveyor, I probably should know, but you know, if it's a cloudy day, you can't see the sun, you're not familiar with the area, you might not know. So I like to turn off, go north, go east, and I like to turn on, go forward, go backward, and go left and go right. And what that does is once I start moving towards the point and I've got my bearing set going to that stakeout point, put the arrow on the screen towards the top, I'm going forward or backwards along that line towards the point and left and right along that point. And it's a lot like staking out with a total station. To me, it makes life really easy, especially combined with the IMU where I don't have to plumb things up. So we'll see that when we go out in the field and stake out a point. But anyway, that's how I like to set things. We'll accept that. And then also for the points and lines, I like to uncheck, go east, go north, south, go east, go west, and just leave on the forward and backward relative to the line. Just unclutters the screen a little bit more. And usually when you're staking out a line, an arc, or a polyline, or even a road, that alignment is where you're going to get your forward and back, left and right from anyway. So again, just makes things a little bit nicer there. All right. Then I'm going to leave everything else on. The only thing down here at the bottom is remove stake point from list. We'll look at this when we go out in the field, but if you create a stakeout list, once you've as staked or stored that point, it'll remove it from the list if this box is checked. And basically when you get to the end of the list, there's nothing else there because they've all been removed. You're done for the day, okay? If you don't like it being taken out of the list, you may need to stake that point multiple times. You could uncheck that box and say, hey, leave the points in the list for me. That's all. I'll hit accept there. Site calibration, we've got a good video on that. We'll leave a link in the description below for how to do a site calibration. It'll explain these settings a little bit more. For now, I would say just leave these set to the default. So we'll accept that. Now, duplicate point tolerance, you may want to change. So this is going to warn you if you store a point with the same name that's, you know, it's got to be identical to it, right? So if we're setting a 0 horizontal distance, 0 vertical distance, any point that's not identical to that point, it will warn you before it stores it, all right? You can set values in there for something else. I wouldn't recommend it. I'd leave it on zeros. That way, if you key in a point number in the horizontal and vertical distance or you shoot another point with the same point number, it's going to warn you and ask you what you want to do with that, okay? So I'd leave that at zeros. Auto average, if you are going out and averaging points up and you want it, you're going to say shoot point number 1, come back later on that day, shoot point number 1 again, and you want it to auto average. If it's within the amount of these residuals, you can set that up to do that. I'm going to go ahead and turn that off. And then proximity check, you can turn that on and set a value in there. This would be like if you wanted to check into control points, but store it and name it something different and then see what the proximity between the 2 points is without having to do an inverse. You can set this up, turn it on. I could go check into my control point number 1 and call it number 1000 just as a check, and this will tell me how close they are to each other, right? It's just it's another way to make sure you don't have duplicate points in the same area as well. You can use it to check, or it can warn you of duplicate points that might be in the same area there. So I'm going to turn that off for now. We're just going to leave the duplicate point tolerances like they were. Tap accept. The other settings I'm not going to open up and cover is to connect to a laser rangefinder, to connect to an echo sounder, to connect to a utility locator, and setting up NEMA outputs from the receiver. So we might do some videos on that in the future, but right now I'm just going to stick to surveying with the RTK and not connecting up to other third-party devices, all right? So we've got everything set. We've got our rover options, our base options, our radios are set up. We've got our auto store set for topo point, observe control point, made the changes to stakeout that I like to make. So we're done here. We're just tap store, and now our RTK survey style is set up. So I'll tap escape. And now we're ready to set up a project, set up a job, then we'll be ready to head to the field. Now that we've got our survey style set up, we're ready to set up a project and a job. Now, we're just going to set up a project locally on the data collector, okay? This is the file structure that is used to sync data between the office and the field using Trimble Connect. So you have to set up a project, and that way that project can live on the cloud and you can send data back and forth. For this example, we're just going to treat it as a file structure on the data collector. So on the data collector, there's going to be a folder called Trimble Data. Inside that Trimble Data folder, there will be a projects folder. Inside that projects folder will be your project, and that project will contain your job file, any point files or background maps or anything like that that you want to use, okay? So that's just your file structure. Trimble Data, projects, the name of your project folder, and inside that project folder will live all your data that you're collecting out in the field or that you're staking out from, right? So again, put my glasses on. We'll go to New up here at the top, and we'll give our project a name. And I'm just going to call this test. I like to be in caps, so I'm going to hit function caps, test. You can give it a description if you want, a reference, a location. You can even take a picture or upload a picture for it. But you at least have to give it a name because we're creating a folder, right? So we at least have to name it. So I'll tap enter there and hit create. And now, since I don't have a job in there, it's going to prompt me for a job. I don't have to create one at this point. I could just create a project, but we want a job so we can go out in the field and survey. So I'm going to call this one test as well. And then there's 3 templates that come with the software that basically set your units up for you: international feet, metric, and survey. Now these are scale only. They don't have a coordinate system or a projection set in them. You have to do that. But this just sets your units up quickly for us. I live in a survey feet state on the East Coast where I am, so I'm going to choose US survey feet, but you choose the units that you use for your location there. Next, we're going to go to coordinate systems. Since we're using GPS receivers, we either need to set up a coordinate system and work inside a known projection, or we need to do a site calibration. Again, I'm going to leave a link in the description below on how to do a site calibration. But for this one, we are going to set up a known projection. So we'll tap where it says scale of 1 and choose select from library. This library has all the coordinate systems for the world in them. Okay, so I can look at this and I can scroll to the one that I need. You know, like I said, there's all these different ones in there. We're going to use, for today's example, United States NAT 83. I am in North Carolina, so I'll hit N on the keypad and then choose North Carolina 3200. All the other stuff you can see there's not a choice for. It's just telling us how it's set up, right? I do want to use a geoid model. Now, if you're not familiar with geoid models, you know, GPS is measuring Earth-centered, Earth-fixed coordinates, converting that over to latitude, longitudes, and heights. And those heights are, you know, based on how high or low the receiver is based on a reference ellipsoid. But that doesn't represent sea level. Normally, if I tell you it's 400 feet outside my office here, you're thinking that that's 400 feet above sea level, right? And that's what a geoid does. A geoid is a model based on gravity that represents where sea level would be. So by applying a geoid model, I'm going to get mean sea level elevations, roughly. All right. So we want to use that geoid model. And the latest one here in the US is Geoid 18 CONUS. Might be different for whatever part of the world you're in, right? So just choose the correct one there. And for this job, we're going to work in grid coordinates. Now, we have some other videos on our YouTube channel that will talk about the difference between grid and ground and how that affects your survey data. But for simplicity in this video, I'm going to stick to grid coordinates. And then I have to put a project height in. Now, this is just a jumping off point. It's basically a rough height for the area you're working in. Notice it says height. Whenever you see height in Trimble software, it's talking about a height above ellipsoid. It's not talking about a mean sea level elevation or a geoid elevation. It's talking about a ellipsoid height, which in my area is 90 to 100 feet below what the ground elevation would be. All right. So if I know it's 450 feet outside, I would put in 350, for example. So I'll go ahead and type that in now. Now, you don't have to be exact with this. The software is only going to use this in certain occasions. It's not going to come into play as you collect data or stake out data. The only time it really comes into play is when the software needs to calculate a scale factor for ground calculations, grid calculations, different things, but it needs to calculate a scale factor and there aren't elevations on the points, okay? Then it needs a ellipsoid height to do the elevation factor part of the scale factor calculation, and that's when it's going to use this. So for most things, it's not really going to use this, just get something close, all right? Then once I've got all that in there, I can tap enter and store. Now, a couple other things. Okay, so it's showing here that, hey, this is a nice feature. You got to have an internet connection, but it's showing, hey, on your data collector, you don't have Geoid 18. Do you want to download it now? Since I'm connected to the internet, it's going to go out there and fetch the Geoid model for me and go ahead and load it in there. All right, so we'll let that go ahead and get loaded up. And once that's in there, now I can store the file there. Okay. Now my units are all set up, but let's take a look at some of the units. Like I said, I used that US feet template, so it went ahead and set my units up for me. But let's take a look at them so you'll know where to change some of them if you want to. So US survey feet for my coordinates and my height. Angles are degrees, minutes, and seconds. So if you were using something different, you wanted degrees, you can do that, set that up, or mils or gons even. Now, if you're working on boundary surveys or you need to enter in bearings, quadrant bearings for direction, by default, the software is set up for azimuth. So you can check this box right here to turn off whether or not you want to use quadrant bearings. That's a question that comes up every now and then. Temperature, pressure, if you're using a total station, you'd want that in there. How do you want your area, your volume, your mass, then your display, okay? This could affect you depending on how you like your display setup. By default, it's always at 3 decimal places. You might only want 2, you might want 4. Everybody's a little different, so you can set that up the way you want it as well. Angle display, station display, depending on where you are. Local time, then your precision display, okay? By default, your precision display is set to DRMS, which is directional root mean square, and that's basically at a 63% confidence level in the horizontal and a 68% confidence level in the vertical, okay? And that's what it's always been. So if you've used Survey Controller back in the day or other versions of Trimble Access before they put this setting in there, that's what you always saw was DRMS for your values at the top of the screen in your precision readout. But if you wanted it 95 or 99, sorry about that, getting a little update from Android there, but you can even do 1 sigma, okay, which is 39% in the horizontal and 68% in the vertical. If you do 95%, then that's 95% confidence level in both of them, and 99 would be 99% confidence level in both horizontal and vertical. So, a lot of times the office is doing work in 95% confidence level because that's what most board rules require and things like that. So if you want to see the same thing in the field, so there's no discrepancy between the field and office, you can change that to 95%. But just know in the field, the precisions you're seeing by default, if you don't change that, are DRMS, which is 63 and 68% horizontally and vertically. All right. Besides that, I'll go ahead and accept my units. My layer manager, this is where I could turn on background maps, point files, turn filters on and off and stuff. I'm not going to do that here in the job settings because we can do that in real time while we're out in the field, and I'll show you that. So feature library would be if you are doing data collection and you want a code library in there that might auto draw your line work. You'll put a symbol for a tree, different things like that. You can choose your codes out of the list. You would select that there. COGO settings. Again, this is by default set to ground. So if I'm doing COGO and calculating up points, it's going to use a ground distance. But if I'm working in grid, I normally like to set my COGO to grid. So I'm keeping apples and apples, right? I'm singing off the same page of the hymnal. I keep grid distances for a grid job, ground distances for a ground job. Tap accept there. Additional settings, let me go through this real quick for you guys. You can have additional settings of descriptions that will actually add description 1, description 2. So when you store a point, you'll get point number, code, description 1, description 2, and you can actually change those headers or the labels to how they show up in the software. So maybe you want, point number, code, and then you want tree trunk size, or, I don't know, whatever, pipe size, if you're doing a big survey that's got those over and over and over again. But anyway, it just gives you another spot where you can type data in, and then you can export out that data to TBC or even into a CSV file that would have the additional information in there. Okay, so I'll turn that off. Feature library, use attributes of base code. If you're collecting attribute data in your feature library and you've got a code that has something added to it, it's going to use the attributes from the base code, so that's good to leave on. You can add to a CSV file. What that's going to do is write a CSV file or a point file in real time as you survey. It's going to basically store a point file for you, and you can give it a name and tell it what folder on the data collector you want that stored in. Now, if you make any changes to the raw data that affect it, it's not going to update this file because this file is being written in real time. But some people like having a backup CSV file, so you can turn that off and on there, okay? I'll turn that off. You can also apply a point name range. So if you've got multiple crews working on the same job, you could give one guy a range of 100 to 1,000, another guy 1,001 to 2,000, another guy 2,001 to 3,000, that sort of thing, so they don't overwrite their points, right? So that is in there. And then also how the next point names show up in your job. So if it's on the last job used, if you're the kind of guy that creates a new job every day, even though you're working on the same job, and you want it to remember what your last topo point was, remember what your last observed control point was from the day before, then you'll want to use last used job, and it'll do that. Or you can set it to a template, and you can put in that, hey, every time I start a new job, I want it to start off with this particular point number here, and use a template. So either way, however you like to run that there, you can do that. All right, I'm going to set it back to last job used. That's the last thing in the list, so we'll hit enter and accept that. Media files, that's if we're using the camera on here to take a picture. It's going to automatically be linked to the previous point, but I can also set that up to link it to the job, the next point, the point name, or none. All right, but that way it will go ahead and link it in the Access software. So when you pull it into TBC, if it's linked to the point, you can click on the media folder next to the point, and you can view the image there. You can also check to geotag the image, and that'll put the EXIF data in there for lat, long, and height. And then you can do some custom naming when it's linked to different entities, right? So I can put in custom strings for different elements on how it's going to show up there for when it's linked to entities and when it's not linked to entities. All right, we'll accept that. Then you could also put in reference, description, operator, and notes. Some people are very meticulous about how they want this filled out, so that each crew chief has that information in there. So you've got that metadata back in the office, so you can fill that in or not. But the main things are, make sure you have your coordinate system and your unit set up right. If you got your coordinate system and your unit set up right, at least your data is going to end up in the right spot. So we'll tap accept there. And now we're ready to head out into the field, set up the base, and start surveying. We're out in the field and we're ready to start our base station survey up. Now, the way I've got my base set up, I've got it set on a 2-meter pole with a detachable tripod. That's good for conditions like this where I have solid ground and it's not a very windy area, but you may want something a little more stable, so you could use a regular tripod with a tri-brack adapter and an extension on it. Just make sure if you do that you do have an extension so that the antenna is not touching the tripod, because that'll cause the antenna to ground out. And once again, we're using the internal radio, so we have to attach this antenna finger tight. You don't want it too tight, right? The other option is you could use like a fixed height tripod from Seco or Trimble that you can get for the base stations as well. They're a little more stable. Again, make sure you have an extension on there so this antenna is not touching metal, it's not touching the tripod or the tri-brack in any way, or it will ground out and you won't get any radio range, okay? So don't forget that. I've already got my battery loaded in there. We showed you how to do that earlier. We're gonna go ahead and turn the receiver on by clicking it once, get the receiver to boot up. All right, receiver is booting up. I'm gonna grab my data collector. And I've got Trimble Access open to the job that we created in the office. So as the receiver boots up, I'll tap the menu at the top left, go to measure. There's our RTK survey style that we edited earlier. And I'll tell it I want to start the base receiver. You always start the base receiver first because it has to know its location so it can send those corrections over to the rover. So I'll tap start base receiver, and it's going to go ahead and connect up via Bluetooth. This may take just a second, and we'll let it go ahead and get connected up. All right, so once it connects to the receiver, it's got a place where it's asking for the point name, has the antenna height information and the measure to information. Now for this example, we've got the base set up on a known control point, okay? And I could import that in. I could go to the menu, key in points, and key that control point information in here. That's what I did earlier, so I just keyed in the control point. But you'll need to have your control point in the data collector, so you can just go ahead and key it in or import it. We'll cover that in another video in the playlist, okay? But what I'll do is tap the black arrow, go to the list after you've keyed it in, and I've only got one point in here. Point number 1, it's my control point. I'll tap accept. My antenna height is 2 meters or 6.562 feet, so that is correct. And then I am measuring to the bottom of the quick release here. If you're using some other form of tripod that has a lever extension, just make sure you enter that information in properly, the correct antenna height and the correct measure to. Once we've got all that done, tap start, and it tells us the base is started. I'll tap OK here. We'll put our hand over there so I can see the lights. And what I'm looking for, I just want to make sure that radio light at the top left is flashing. That lets us know that the radio is transmitting and we're ready to start up the rover. Okay, so we're over at the rover. We're ready to start that survey up. Now I'm using a 2-meter fixed height pole, so I have 2 meters programmed into the survey style there, and it's going to the bottom of the quick release. All right, if you're using some sort of adjustable pole, just make sure you take note of that when you go to measure points. We'll take a look at that in just a second. I do have my antenna attached. Remember, you got to have the antenna on both receivers so that the radios can talk to each other. Again, just finger tight. Make sure it's on there, but it's just finger tight. And I've got my data collector attached with the bracket that comes with it. And this bracket's adjustable. You can push the button and you can lean the screen to get it to where it's comfortable to your eyes. Raise it up and down on the pole where it's comfortable for you to view. Okay, once I've got that all set up, I'll go ahead and press the power button once to turn the unit on. It's bright out here, so I cut my hands over it just to see that the lights did come on. And you can see in Trimble Access, we're still connected to the base. It's only about 30 feet away from me right now. I always like to go ahead and get the rover started while I'm near the base. That way, if there's any connection issues, I can always go back to the base and check it out. So we'll go back to the menu at the top, choose measure again, choose RTK, and we'll start off by measuring some points. So we'll choose measure points, and you'll see the data collector is automatically gonna try to connect up to the rover that we put in there in our Bluetooth settings. So we'll give it just 1 second to connect up. All right, you see connected to receiver there at the top, and you'll see it pop up and it said face LED panel, right? There's that number 22 we saw when we started the base. So I know that I am connected to my base station, 100% reliability there. And up at the top, you'll see the radio symbol has little yellow waves pulsing out of it to let us know that we have radio. And if I look on my receiver, that radio light is lit up on the rover. So I know the two are talking to one another. So I'll tap the accept button. Again, face the LED panel. Now, since I'm using an R980, I do have to initialize the IMU, okay? This is not calibrating the IMU. You rarely have to do that on these 980s. Every now and then it'll pop up and do it. I know some manufacturers make you calibrate it every time. We just have to initiate it, all right? Just the easiest way to do that is walk around or do what I call stirring the drink, right? Just stir it up a little bit. You wave this thing around in all 4 quadrants. You'll see now I got a green check mark up at the top instead of the red X. that means it's initialized. It just needs to move around a little bit so that it knows where it's at, okay? And with that IMU initialized, when I go to measure topo shots, like if I want to take a ground shot right here, I don't have to plumb it up, okay? It's always doing the math down to the tip instead of up here at the receiver like the older receivers did. So I'm going to start off with a point name. Now, a point name is normally a number in the survey world, and that's just the unique identifier in the database for every point that you measure. So since I started my control at a low number, I'm going to start my topo points up here at a little bit higher number. I'll start that at 100. And this will be a ground shot. You know, you can use codes. We'll have another video on how to do a feature code library, so you can check that out. Right now, I'll just type in some codes to describe what I'm measuring. I'll use GS for ground shot. Now you have different methods here. If I do the drop down for method, a topo point is a 2-second shot. We talked a little bit about this during the survey style setup. That's going to be a 2-second shot, and that gives me one measurement and another measurement to compare it to, just to make sure that everything is working well. Rapid point is just one measurement. You hit the button, boom, it takes a shot. Observed control point is a 3-minute shot. So if I needed to set another control point somewhere, I'd hook a bipod up to this guy, because I'm not going to hold it still for 3 minutes, and I could take an observed control point. That just gives me 3 minutes worth of 1-second observations, all averaged together, so it gives me a better quality point there. Now, a calibration point is what you do when you're doing a site calibration. You can check out our video on site calibrations to see how that works. And then we'll show you how to do a horizontal tilt offset. But basically, that's where you use the IMU to put the tip of the pole at the base of the object you want to measure, and it will use the direction and the distance to calculate up the center of that object that you're trying to offset to, right? So that's the horizontal tilt offset. So out here to take a ground shot, I'm just going to use a topo point, all right? I do want to double check my antenna height is correct, 2 meters, 6.562 feet, and I am measured to the bottom of the quick release here. So once all that is done, I've got my point name, my code, I've double checked everything. I'll hit the enter button. Now you can tap on the screen here, or you can use the enter button on the actual keypad. I like using that because it's easier for me to hold the rod with one hand, the data collector with the other, and just hit enter and measure. So again, I don't have to plumb it up. I've got the IMU rocking there, so I'm just gonna hit the enter button. That's gonna enter that information. Then I'll hit the enter button again, and it's gonna measure for 2 seconds.
Observation stored.
It auto-stored it. We hear observation stored. I know it auto-stored it because remember when we set up our survey style, we checked that box to auto-store. If it doesn't auto-store and it comes up with a store button at the bottom right, all you have to do is hit the enter button or hit that store button, and that'll store it. Okay, now we're all set where we can move to another point. I'm gonna stay in camera view because I'm out here by myself, so I can take another measurement. Again, I don't have to plumb it up. RTK plus IMU is up there at the top. And I could just simply move around my survey site, taking measurements and getting everything measured, changing the code as needed. Now, let me just show you guys one other thing. Up here at the top of the screen, you'll see it says RTK plus IMU. It gives us H is 0.04 survey feet, V is 0.05 survey feet. Now, that is our precisions. That's how close the software thinks we are. All right, and that's generally going to be in the right number. And that goes back to that either DRMS or 95% confidence level that we saw in the survey style that we talked about earlier in the video, how you want to see that information. And then there's a green check mark there. That means the software is happy with our position. We meet the criteria that we set up using that auto tolerance when we set up our rover options earlier as well. If you see a red X up there, you'll notice your precisions are a little bit higher. It just means you're out of the range that you set for the software. You can still override it and take a shot, but you want to look for that green check, and you want to make sure that those numbers up there at the top are in that range that you're looking for your precisions. And at this point, it's just wash, rinse, repeat, right? I could change the code, I could change the point numbers, I could go from a topo point to a rapid point, and I just got to hit enter. Oh, let me go to my find next to get my next point number. And I'm gonna start with 100 because I can't remember. That's a neat little trick. and it's going to go to 103 for you. So when I changed methods, it changed point numbers because it's giving you a chance to group them differently if you wanted to. All right, so I'll hit enter, measure this. And again, since it's a rapid point, it's just 1 point and move on. All right, but that's how easy it is to go out and gather information there, is just to set it up for a topo point, set it up for a rapid point, set it up for a control point, whatever you're gonna measure, and hit the measure button, the enter button, and wait for it to store it. All right, now another thing you might want to do besides measure points is stake out a point. Remember, this is just a getting started guide, so we're keeping this really, really basic, just enough to get you out in the field, get you up and running. But if you wanted to stake out a point, now that we've measured a few points and I have some points in here, I'll go ahead and show you how to stake one out. Now again, you could go to menu, key in, and you could go to points and key in points that you need to stake out, or you could put them into your project folder and then use this layer button over here at the side to go ahead and use your point file that you've added in there as a text file or a CSV file. Just place that in the project folder on your data collector and it'll show up in the list, and you could add those points through the layer manager as well. Okay, so either key them in or use the layer manager if you have a point file electronically. All right, I'm gonna go ahead and escape from this back to the main menu. Two ways you can do it once you do have points in the job, okay? If it's on the screen, like if I wanted to stake out number 103, let's say, I could tap on 103 and you'll see stakeout pops up at the bottom, and I could just stake it out. Or I could go to menu, stakeout, points, and I could tap 103, or I could key in 103. If I go to point down at the bottom, I could key in 103, enter, and stake out. So either way you want to do it, pick it off the screen or go through the menu, either one will work. Now you'll see I'm really close to it, so let me back off just a little bit to show you how the screens change the closer you get to the point. So I'm going to back up just a little bit. And you'll see on there, it tells me I need to go forward and I need to go left, right? And that's, once I start moving, that's why I changed that in the survey style, because to me, that's really handy to kind of know once you get on a line of where you're going towards the point, I need to go forward 3.5 feet and I need to go left 2 feet. So I'll just slowly start moving. And again, I don't have to plumb up because I've got an IMU, right? Now I overshot it a little bit, so I'm gonna go backwards and left. I'm pretty much on line there. And now I'm within a few hundred. So depending on how accurate I had to be, I could get it a little bit tighter, but I'm within a couple of hundreds, good enough for a stake. I could put my point in the ground. I could measure that and store it as an as stake point if I wanted to. So I could go measure. It's gonna give it an auto point name. I could give it my own point series. I'll go ahead and jump up to 1000. You'll see it codes it 103, right? Because that's the point number that we were staking out. That way you can identify what you were staking out in the office. Enter, measure that as a topo point. All right, now you don't have to as stake your points if you want to and store them, but a lot of people do. So this will show you your deltas. The guys back in the office could see that as well. So I'll store that. And now I'm gonna go ahead and I will go to, that was the last point we shot. So I'm gonna go ahead and stake out 101, stake it out. And you'll see I need to go forward 1.3 and left 1.6. And again, the nice thing about this is I don't have to plumb this up. So backwards 3/10, left 5/10. Just keep moving until it's good. Pop a hole in the ground, put a stake in, measure it if I want to. Okay, so real quickly, we showed you how you can get the base set up and going out here in the field after you've set everything up in the office. Showed you how you can start the base on a known point, showed you how to measure points, and then also showed you how to stake some points out. Next, we'll go back in the office and export out a CSV file for use and a job file for use in the office. But first, let me show you how to shut down the base in the rover, because there's a certain way that you should go about shutting it down. All right, so I'm gonna escape out of stakeout, escape all the way back to the main screen, go to the menu, measure, and I'm gonna say GNSS survey here at the rover and tell it to power down the receiver. Now I've seen guys pop the battery door open and take the battery out to turn it off. I've seen guys turn it off here with the power button while it's still connected up. If you'll follow that way, where you go to the menu and you go to measure or stakeout and choose GNSS survey for the rover, power it off through the data collector, that's gonna make sure that your ports are always freed up. It's not gonna jam up your Bluetooth ports between here and there. It's also not gonna create issues with the receiver while you're turning it off while it's in the middle of running as well, right? Now, I'm still pretty close to my base station, so I'll tap on the menu, go to measure, RTK, and tell it to end the GNSS base survey, let it connect up and power down the base through the data collector as well. And again, that's just going to prevent problems down the line. That is the proper way to shut your equipment off. So we'll give it just 1 second to connect up to the base, and we'll turn it off through the data collector. Okay, so now that it's connected up to the base, you'll see it gives me the option to power down the receiver. So I'll say yes. That's going to turn the receiver off, turn the rover off, turn the base off. We're ready to box everything up, head back into the office and do a little exporting. See you there. So we're done with the field work. We're back in the office, and we need to transfer the points we collected out in the field over to our computer. As part of our Back to Basics program, I want to keep this really simple and just show you how to create a text file or CSV file and then transfer that via the USB cable that comes with the TSC5 over to your computer there. So the first thing we'll do is go to the menu at the top left. We'll tap the job name, and down at the bottom, there's an option for export. We'll choose export, and we're going to use the drop down to select comma delimited, CSV, and text. The file name is going to default to the name of your job. You could change that if necessary. You could also tap the black folder button next to the file name to select a different folder to save it to. Usually you can just leave it where it is. What it's going to do is it's going to export it to the project folder. All right, that keeps the job and any exported files all together in that project folder. That's what I'm going to do, is just leave it at the default there. You can also set the fields up by default. This is going to do field 1 is the point number or point name. Field 2 will be your northing, then your easting, your elevation, and your code. It's also going to do it as comma delimited, which is pretty standard for survey stuff, but you can do the drop down there and change that to a space or something else if needed. So I'll tap accept here, and after I tap accept, it'll give me an option to choose the points in different formats. You know, if you've been out there and you did a survey and you just want all the points, that's simple, just choose all points, but you can choose them by point range, point number range, by code, by name, whatever there, just select them from the list. I'm going to do all points, and the transfer is complete. So once I have exported those points out, they are in the project folder on the data collector. I can connect my TSC5 to the office computer there with the USB port on the bottom. Now, one real quick thing that messes people up the first time they use a TSC5 and try to transfer data is this message will pop up on the data collector, and you have to choose file transfer or it won't show up on your computer. Okay, so once I've chosen file transfer, in my file explorer on the computer, I'll get an option for TSC5 over here at the left-hand side, and I can double click on the internal shared storage, go to my Trimble data folder, then go to that projects folder, and there's my test project, and there's my test.csv. I can right click and copy that and then paste it into whatever folder I need it on my computer, and I'm all set with getting my point file of the stuff I collected out in the field from the data collector over to the PC, and I can put it in whatever CAD software I want to work in. All right, so that wraps up our getting started guide for RTK base rover using R980s with internal radios and a TSC5 data collector. So we showed you what comes with all the gear. We showed you how to set it up, put the batteries in it, charge it, all that good stuff. Showed you how to set up a job and a project and a survey style in Trimble Access. Go out in the field, do some point data collection, measuring points, and then do some point stakeout. And then lastly, we brought it into the office, exported a point file, and transferred it over to your PC. So again, a basic getting started guide for you to be able to take your new Trimble equipment out in the field, get some work done, and get it back in the office. So that was the first in our Getting Started guides for our Back to Basics series. This was on RTK. We'll fill in the gaps. Again, we kept this pretty basic to start with. We'll fill in the gaps with some of the more advanced things you can do with these units and with Trimble Access in future videos. And we'll also have a Getting Started guide coming up for the robotic total station as well. Hey, thanks for checking out Survey Matters with Duncan-Parnell, and I'll see you on the next one.